When I sliced up this section on parametric equations, I put it into three pieces, but as I looked closer at this in preparation, I don't think that was necessary. There's really nothing particularly new here in this last section that couldn't have tied into the last video. But let's go through it here and we'll just strengthen our skills, I guess. So this is asking two different methods to turn this parametric equation into a Cartesian or rectangular one. We've already seen how to do this. All we need to do is solve one of these for one of the variables. So we could have solved this two ways. We could solve this for y and then solve that, so t would be y minus 1 equals t. This would be the easier way. You'd go back in here and then wherever there was a t, you now replace it with y minus 1. Or you could have chosen the other way. This is what we'll see in just a second. We could have solved the top one for t, which would be x plus 2 divided by 3 equals t. And then you'd sub that in to the second equation. So that's what they're doing here. First method, they solved the x equation for t, sent that in, subbed it into this. Now they've done some algebra to tidy it up. It's not that tricky and it's not all that important, but they get down to here. So this is a line with an intercept of 5/3. But we could have equally chosen to go the other way. Suppose we had solved the easier equation for t. And now if this is what t equals, we could sub it in for the t in the other equation. And we get to the same point. So two different ways to get there, but in both cases we get the same line. Okay, how about this? Again, we can do this multiple ways. I'm going to solve this x equals t to the third. So if I'm trying to solve for t, do you see that it would be the cube root of x? Okay? Now I'm going to write that as t as x to the 1/3 because it's going to be helpful in a second. So if this is what t equals, I'm going to sub that in here for t right here. So y is then equal to x to the 1/3 all to the 6th power. So a power to a power means we multiply those. So x to the 6/3 is going to be x to the 2nd. And we have eliminated the parametric aspect of the equation. Okay. All right, so they want us to find some parametric here. Yeah, I remember this one. This is a bit of a weird example. So here's what we would have done. If it's our discretion on how we want to turn this into parametric, what we've been doing is the most simple one. Let's say x is a function of t and we make this direct substitution. T is now directly varying with x. So all you'd have to do then is just replace all the values of x with t. Now, they made another change. I don't even know what the point of it was. I guess it shows you could make any change that you wanted and you could still get there. They made the change x is t plus 3. I don't even know what their point was, what it was trying to help them show you, but it creates the same graph. Maybe that was their point. That even though they made this different parametric change, it's still going to get the same graph. So again, the more natural response here is let's make this change, and then our equation just becomes this. We replace all the values of x with t, and there's our new set of parametric equations. Okay, yeah, I totally should have put this together with the last video, but just a few more reviews for you there on how this works.